Okay, so good morning guys. So record na nato, no? So welcome again to Process Automation 2 Control. Okay, so we'll be discussing the part 2 sa kaning PID control modes. This time it is proportional. Okay? So you can now chat your you can now chat your last name, first name, then ID number sa inyong attendance. Okay? Sige daw. Pag-attendance daw mo para akong tanawon sa chat. Wala pa may nag-attendance.
Again, sir, ito, sir. Last name
Ayun
and
last name, first name, dayon, ID number. Bali, apelido, imong pangalan na first name, then ano ka na. Okay na siya, Webster. Okay, very good. Okay? So, attendance. Then, by the way, no, wala man na record gani ha. Nagbutang ko kuan activities or quiz no regarding the previous topic, the on-off no control mode, no, particularly the on-off relay-based control, namely the float switch and the floatless relay. So, atong tanawon kuan para na may idea ko. By the way, giset na lang na ako sa kuan no, 3 attempts kay para magtuon gid mo no, dili mo mag trial and error. So mura nani ang gawas no. Construct the raw water control system, blah blah blah. So mao ni atong kuan no. Ito scenario no na diri ang kaning mga control circuit and mao ni imong identification part sa imong raw water level system. Dayon, you're going to do that in 15 minutes. Okay, so number 2 na question, same gapon. But this time, it's using a vertical float switch. So, float switch siya, pero dili katong dili katong previous na float. Kani kay kuan na siya vertical na type. Okay, so mananata ni the last time, ato lang ni i-review. Okay? So, katupong sa kuan, ani pong sa on-off relay-based control using floatless relay. So, it is still a relay-based na na control, particularly an on-off control. So, tanaw na natin sa mga gawas. Preview quiz now. So, this is for 15 minutes. So, inani no, just like the last time, maragapon. So this time it's using a floatless relay. Then it has 3 items, 2 items. So kani, gawas na yung kaning relay unit nimo. Okay? So asa ka diya ang wiring, you need to review. Oh, balik-balik na ni na style. Bantayan na ninyo ang power niya, supply, then what is the initial position sa selector switch or selector ba? Yeah, it's a selector switch. Okay? So I'm going to stop now the sharing. I'm going to share my slides. Kanin siguro slides. By the way, katong dili mag-story, kindly mute your mic, no? Para kuan. Para dili ma-appear sa recording. Okay. Okay, so again, PID controllers can be set into different control modes, no? And we're done with this on-off control. In fact, bago lang ko nagatag o review na activity or quiz. So this time, we're going to discuss the proportional control, no? The part na letter P sa imuhang control modes. Okay? So proportional. So, unsa man siyang proportional control, no, the mode. So, it is a type of linear feedback control system in which correction is applied to the control variable which is proportional or linear, no? You say proportional, it's a straight line, no? It could be either kuan siya, slanting line, no? Wala na, slanting line, which is proportional to the difference between the desired set point value and the measured value or the process variable, so PB. So if you're going to look that in a block diagram na format or a figure, sinani siya. Okay? So if you're going to compare this with the PID system, tulo ang PID, no? Na kay proportional controller, na kay integral controller, and na kay differential or derivative na controller. But this time, it's only using proportional. So isa ra. No, isa ra. Okay? So example, let us say na kay set point which is equal to 7. No? Then let us say along the process, no. Let us say your proportional gain, no, KP, no, proportional gain is set to equal to 1. Okay, so technically, let us say na kay output, no, na kay process output or the PB, na kay 4, 7. But this is a summer, no, summing device. So this is 7 minus, no, the difference between the set point and the process variable as defined, no. So 7 minus 4 is equals to 3. Okay, so 3 ang imong error, no? Error na function. And since this is linear, i-multiply ra na nimo, no? 3 times 1. So therefore ang output nimo is 3. So maragi na ng idea, no? Okay? So another example. What will happen if you're going to set your proportional gain is equal to 2 or KP is equal to 2? Okay, so with the same set point and the process variable, no, value, so you'll notice that 7 minus 4 is 3. But since the proportional gain is times 2 naman, so i-multiply nimo siya 2 times 3. So this time ang output na nimo is 6. Okay? So unsay pasabot ana, no? If the gain increases to 2, the output doubles. So ang output nimo diri sa imong controller is nag-double siya, no? As based sa previous na the output is 3. Diba 3 siya? So this time it is 6. So double siya. So this means that the controller reacts faster to correct the error. Okay? So take note, ang error na to is 3, no? Pag i-minus nimo ang 7 minus 4, so napag-apple siya error. Okay? So, para ma-meet niya diretso na as much as possible, ma-zero niya ang error, dapat patasan niya ang proportional gain para dako yung output. Okay? So, that's the bottom line, no, of how a proportional controller behaves, no, or iyang function as the value of its proportional gain increases or decreases. So, mo-double siya. So, kung tanaw na to sa graph, so we're going to compare the left, no, picture and the right picture or the diagrams, no. Unsa yung na-notice ba? Pareha ra bagid sila? Pareha ra bagid siguro in terms of let's say lines, no, lines na mga drawing. Pagkaingon kag pareha, no? Pare-pareha sila lines. But let us consider the time. Tanaw yung time na aspect. So if the proportional gain is or KP is set to 1, you notice that ang iyahang response, no? So linear magyapon eh. Pero if you're going to check kanina time, taas-taas ni siya as compared there is a pikas. Diba? Notice niyo ba mas taas-taas, mas dali rin ni siya compared to dire. So may pasabot atong if you're going to set the proportional gain higher as compared to 1, no? Kung 1 lang siya, so dugay kaysa mo musaka, no, or mo change yung output. Whereas dire with a shorter amount of time, nakasaka din siya diretso. Okay, so mo ni pasabot sa imong uh, how are you going to interpret the graph. So basahan ninyo the same thing sa akong giingon. Okay? Na may panguntahan na. Okay. Uy, na may video link. So ato ning tanaw ng video link. Okay, so this is an example of proportional na control, no? To understand the characteristic of proportional control system, examine the system. Now, this shows the initial startup condition of a system using proportional control to maintain a constant level, no, or the control variable in the tank. No? So, initial condition at the startup, there is no flow in the tank, so there is no liquid in the tank. So, may kita niyo empty. So, I'm going to stop sharing. Pero ako sa i-click ang link. Okay, I'm going to share. Asa naman itong gawas? Okay, kani. I'm going to share the sound as well. Sige, ito na yung padakon. Igna ko ninyo kung di madunggan ang kuana.
System shown here. This shows the initial start.
Akong gi-post, madunggan ninyo ang sound.
Madunggan, sir.
Okay? Very good. So, akong ibalik. Sige.
Okay, sir. Salamat.
The characteristics of a proportional control system. Examine the system shown here. This shows the initial startup condition of a system using proportional control to maintain a constant level, controlled variable, in a tank. At startup, there is no flow into the tank, so there is no liquid in the tank. Level control example. This example shows the condition after the operator has set the controller SP to 60% with a gain of 2. With an error of 60% and a gain of 2, the output of the controller should be 120%. However, the internal software of the controller limits the maximum output to 100% or 20 milliamps. The 100% output from the controller causes the IP converter to fully close the control valve. When liquid begins flowing into the tank, the level in the tank begins to rise toward the SP at the maximum rate. Here, the level has risen to 10%. At this point, the error is still large, and the controller's output is still at 100%, keeping the valve fully closed. This allows the level to continue to increase at the maximum rate. At this point, the system acts more like an on-off system. This is a typical characteristic of proportional systems. Level control, PV near SP. Eventually, the PV reaches a point that is close enough to the SP for the controller to begin proportionally decreasing its output to open the valve. This causes the rate at which the level rises to begin to slow. The amount the valve opens is proportional to the error that remains in the system. Here, the valve is partially open when the PV reaches 35%. At this point, the output from the controller is only 50%, so the tank is now only filling at 50% of the rate it was when the tank level was lower. Different proportional gains. The point at which the controller begins to control the level proportionally depends on the gain setting. A low gain results in proportional control over a wide range of the valve's travel. A high gain results in proportional control only in a small range of the valve's travel. Steady state. The controller continues to open the valve in a proportional manner, which slows the rate of fill and gradually allows the output flow to equal the input flow. When the input and output flows are equal, the difference between the PV and the SP holds the controller output at a constant value, and the PV settles, or the system reaches a steady state.
Okay guys, so nasabtan ninyo no, na-demonstrate niya na if the proportional gain is set to 2, no, Di ba ang output niya ato murag kuan siguro no, the set point is set to 60. Pag i-times 2 nimo siya na 120 or na 120%. So ang point dito is if you're going to increase the proportional gain KP, mas taas siya as compared to 1, dali ra niya i-reach ang imong kuano desired na output or set point. Kaya nga naman ang kuan na ato ang kaning iyang bulb dili man niya i-open, so close man siya, so 100%, so sirado siya, no, sirado after considering na wala pa sulod ang tank, so no, so 120%, pero ang iyang i-execute ra ato kung 4 to 20 milliamps na siya, kung kadumdum pa mo atong formula na to the last time sa to ang kuan process control 1, process automation 1 rather instrumentation 1, no, 4, ang 4 nimo is 0%, ang 20 nimo is 100%. But since the output sa imong proportional controller is 120% man, so bali ang i-execute ra niya na ang 100% ra gyapon. Okay, so ang point dito is dali ra siya mo maabot sa iyang set point considering nag-double nimo siya as compared kung i-times 1 lang nimo na dugay kay siya makaabot sa set point to the point na dugay pa ni ka-open ang imong bulb. By the way, this bulb is set to be reverse action, no? No, reverse action. Dili siya direct action. Naman ay setting sa imong kung ano, sa imong temperature controller na siya reverse action o direct action. So depende ra na siya. No, kung gusto nimo na logic kuan siya, no, negative logic na sirado sa siya to 100%, reverse action na tawag na. Pero pag open siya pag 100% man ang direct action. But anyway, I'm going to stop the sharing now. Share na to balik to PowerPoint. PowerPoint kami. Okay? So, I hope na nakita ninyo ang ang video na what's the advantage between KP is just equal to 1 as compared to KP is equal to 2 or higher. Okay? Gibalik ra gyapon ni siya na na example. So, take note, ang KP na to na example na is 2. Okay? So, the steady state error that remains is a characteristic of proportional control called proportional offset, no? Or simply offset. So, mao na to ang difference between the set point and the process variable na output nimo. Okay? Mao na ang difference nila, offset. So, these errors must exist so that the controller can generate an output that holds the control valve open. No? Open is a style kay kung ano na siya reverse action. No? At the point where the flow in the tank equals to the flow out of the tank. Now, if the error were 0, the control valve would be fully open and the flow out would be greater than the flow. So, that's why kaning offset na to, no, dili necessary na 0 gina nga tong offset, or else ang ato ang valve makalitan siya open na 100%, so bali there will be drastic na decline siguro sa imong sa imong volume or liquid level sa imong tank. So may pasabot ani, no, na dili necessary that the steady state error is equal to 0. Pwede ra duol sa duol sa imong set point. Mo na. So man yung disadvantage pag is 0 gini mo imong offset. Kalit na siya open, hurot sa diretso, so dive diretso ang imong level, no. Dako na nun niya offset as compared sa kaning minimal lang na offset. Manang if the error were 0, the control valve would be fully open. So, mano siya. Now, doesn't mean na ang imong offset is dili 0, dili na siya stable na system, or it has in the steady state na condition. in kaning gitawag nila na diagram. So kanina diagram. So kung nag-study siguro mo kaning sa inyong circuits, no, RLC or RC na circuit, so nanay gitawag na kung ano kana response sa imong sa imong output sa imong circuit. Ang primero na response is gitawag siya transient response. Now for any type of system, control system, lagi na siya inana, no, pareha sa elevator. Pag-on mo na sa imong pag-on mo na mo andar ng elevator, dili gini siya diretso na steady state dayon. Notice na nimo ang elevator, vibrate na gamay, no, nakikitawag na transient response. The same is true sa mga machines, no, sakyan na, motorcycle. So di na siya diretso dayon na kung unsa imong desired na output, steady din siya diretso. Sa nakikitawag na transient response. Okay, initial response. So for our system, inani na siya, no, normally, no. Let us say the set point is kani. So pag sugod mo magkalit na siya o kanang rise and fall and so on and so forth. Okay? So until ma-reach na ang gitawag na steady state na condition. The same is true sa imong katuwa ang tank na to. Steady state na siya na constant na iyang level sa tubig. So, pasabot steady. That is what is meant to say steady, no? Gapundo ra siya. But then again, there is still an error. Steady state error. Normal na error. But then again, it is reminded that if you're going to set that to 0, no, kung ma-0 ang imong steady state error and you're just using only proportional control, basig mo balik na po na siya sa katong unstable niya na condition. Okay? So, mga to ang kuhan niya pasabot giniya. Okay. Okay, so the goal of the proportional system is to provide an immediate response and to achieve a steady state with minimum offset error. Minimum lang. Dili kay dako ang imong error. Okay, so the amount of offset in the systems depends on the proportional gain or ganin mo ang KP. If the gain the proportional gain is set to low, the system reacts slowly, and large offset occurs as shown in the diagram. Karon, take note from KP is equal to 1, the proportional gain is equal to 1, or small gain setting. This time we're going to set a scenario where there is a large gain setting or KP nimo is equal to 10. Okay? So manotice nimo po dire, if the gain setting is high, the offset is made smaller. No? Gamay na iyang offset error. No? However, a large gain setting also results in more oscillations in the system because the controller tends to overreact. So, ano yung problema? If you have a larger na proportional gain, overreact siya always. Okay, dako kalit siya og saka, kalit siya og naong nana. So the tendency of the controller to overreact for the error as the gain increases is also the reason that the gain is not simply set as high as possible in an attempt to eliminate the offset. Matong gingon na dili pud maayo nagamay pud kay mo offset error. Kay mo to ang tendency, no. Ang gamay pud kaayo basig gipatas-an nimo ang imong proportional gain, no. Mao na iyang disadvantage. What is important is the steady state. Steady gid siya. No? Balag dako siya og ganing offset error as long na steady lang, no. Okay, pwede man na nimo i-adjust na sige, taas-taasan na lang ako ang set point so that the margin na iyang i-generate na error is actually ang katong imong ang chosen na set point. Bali set murag na kay gitawag na set point 1, set point 2 kung ginana bali, no. So bali arbitrary ra tong gitawag nimo na set point 1. Bali ang katong set point 2 nimo matoy mo igo sa imong offset, no, para maigo niya ang This is only valid for proportional lang na control. Okay? So, dili siya valid pag PID, no? No, okay, tulo naman siya ka command controllers. This is only valid. If you're just simply using a proportional control, matay man technique, no? The ultimate goal is to have a steady state, steady. No, dili ga utro-utro ang iyang output. So, mana. Then, to have a steady state, dili necessary na ang iyang steady state error is almost zero. Okay? So, wala pasabot. Okay? So, inani po na may tabo when ang proportional gain ay sobraan kadako, no? Allow me to show the video. Okay? And then ako din stop sharing. Pamitawan ako itong i-share na ako. Mga kami. Ay, sayo. Share. Nasam itong i-share. Ato ra.
If the gain continually increases, the system eventually becomes unstable.
Guys, nakita ninyo? Ano sa may naitabo? Kay ihimo naman natong 15 ang iyang gain. No? Proportional gain. Isa nyo na-notice. Mas ganyan na lang sa picture. Isa nyo na-notice. Na-notice din nyo kay sige mo siya paspas man kayo siya maka-recover kung detail. Kasi nahurot siya for nakuhaan ang iyang liquid na kuha, no? Dari sa tank. Dali ra kayo siya kasaka. Sa sige na saka, at sa initabo, niawas. Diba? So, niawas siya. So, mani disadvantage ni kaastra kayo ang proportional gain. Okay? I hope na nakita ninyo. Okay? Okay, so di na nato ni ipakita ang kanina video. Okay, balik-balik na niya siya na idea. Okay? So, mag-knowledge check daw ta siya. Kung sa may ibutang na ko KP is equal to 1 or KP is equal to 2? Dire. How about this one? So, compare na tong duha. Natay na notice. In terms of lines and triangle, same na siguro siya, no? Pero na siya difference. Ang tawagan na is the response time. Ang response time nila, dako kay difference. So, asa man ang sa may answer aning diri na kuan diagram. Very good. Very good. KP is equal to 2. Because we're just comparing duha raman. No? Lisod po kayo kung daga na itong ikuan. No? Duha raman. So, obvious, this has faster response. So, therefore, asa may mas dakuan nila ang 2. So, this is 2 and this is 1. Very good. Okay? So, next. So, we go now to what is known as the difference between the terms, no? Proportional band and the proportional gain. So ganiya, we always talk about proportional gain, but this time we introduced a keyword proportional band. So unsay kalainan sa band o gain? So mao na rin yung formula. The PB now, or the proportional band, is actually the reciprocal or multiplicative reciprocal of the proportional gain, or inversely, no? Multiplicatively inversely proportional, no? Proportional gain. Okay? Okay, so let's continue. Okay. So, mana no, KP is the proportional gain and PB is the proportional band. Now, this is very important because if you're going to look the details of the different parameters, advanced parameters of any controllers, no, ang ginagamit na nila na word is proportional band. No? Dili lang proportional gain. No, proportional. Gagamit din sila ang proportional band. Okay? Okay. So, mo ni ang ano. So, sa naanda na to ang proportional gain, kung 100% siya, so, kung 100 siya, imo na siyang i-inversely proportional, 1 divided by 100, so that is 1. 1%. Then, sa 10%, sa 2, 1 divided by 2 is 50%. 1 divided by 1 is 100%. Okay? And so on and so forth. So, bali, kuan ka sila inversely proportional. Kung dako yung proportional gain, ang proportional band mo is gamay. Okay, so na yung mga problem na inaani, no? Dili na ang proportional gain ang ihatag. Proportional band na. No? Let's say the proportional band is set to 20%. Siya pasabot ana. Si pag-interpret ana. Let us say the set point is 10 meters. So therefore, musaka na siya og 12 meters, munaog pala siya og 8 meters. So giunsa man na siya. The proportional band, no, better quantifies what happens with the process by describing the range na siya, no, in which the process variable is proportionally controlled. So, ang given is the set point is 10 meters, then the proportional band is set to 20%. Mo na yung given. So, then, of course, ang ganihang operating range, no? Unsa ni kataas ang imong tank from 0 to 20 meters. Okay? So therefore, you're going to compute what is the 20% of the maximum range. No? Unsa may 20% sa imong 20. So that is 4 meters. So therefore, no? So, therefore, 4 man na siya, no? 4. So, sa kanina, taas o upper range and lower range, dapat 4. So, therefore, kung 4 siya, no? Kung 4 siya, so bahino na nimo 2 diri sa taas, 2 po diri sa taas. So, therefore, 10 plus 2 is 12. 10 minus 2 is 8. So, therefore, the range now is 8 to 12. Okay? Ang gets ba? Okay. So, muna ni yung scenario. Diri na kuan na setting, diri na kuan, the valve is fully open. And diri po sa ubos sa imong proportional band, the valve is fully closed. So outside the proportional band, the control is not proportional. So dili na siya linear. Okay? So the valve is either fully closed or fully open, as shown diri outside the proportional band. Okay? So, moto siya. May pasabot sa yung proportional band. There's only proportional response or linear response within the 20%. Outside the 20% na range, dili na siya. Mura na siya on-off. On-off the system. Kaya naman, it's either fully open or fully closed. Okay. So, the bulb life with large proportional band. So, sa'yo pasabot kung dako kay mo ang proportional band. So, gamay kay mo ang proportional gain. Inversely proportional man sila. With large PB, the operational life of the bulb is extended because the valve does not have to travel frequently between fully open and fully closed. So, gamay man siya proportional gain. So, dili kay siya kasaka ng dugay kay siya musaka, dugay po siya mo naog, or dugay kay siya mo open, or dugay kay siya mo close. Mga na iyang advantage when the proportional band is large. So makita niyo mo din taas yung time na spend. Taas na Whereas Now, whereas if you have kung ano, is small proportional band, so kasabot, narrow na kay paspas lagi sa gasaka una. This means that the bulb moves proportionally through a small range of its full travel. No, this results a fast system response and a small offset. However, when an upset, no, kung maulit o makalit lang drastic error ang imong system, upset imong system, the system tends to oscillate no more before settling no, into a steady state. So, mura pa na kung sa elevator pa, sugot ka na before ka ka-reach sa imong destination na floor, magsayaw-sayaw sa ang imong ganing car, no, car by term na sa kuan kaya sa imong elevator ka na imong gisakyan magkuan sa mag-swing up and down, so sugot ka na inana, no, so dili siya maayo. So that happens when you have a small proportional band, no, murag mag-oscillate siya, no. Okay, so that's the difference between a large proportional band and a small proportional band. So diri before siya ma-reach na yung steady state, no, before ka reach sa imong destination sa elevator, magsayaw-sayaw sa mo dito sa taas, sa kuan, within the floors, between floors. But this one, slow kaya ang response. So, dapat gina-balance din mo ang proportional band. Not too high, not too low. Uy, nabalik-balik lagi ni. Okay. Oh, test na ba eh. So, it's knowledge check. So, unsa may ibutang na ko diri sa permiro, kung if I have a proportional gain, no, or KP is equal to 100, pero unsa ko ibutang diri? Very good, very good. Naagi na minaw 1%. How about this one? Very good. Kabalo day math. No? 1 divided by 10 is 10%. How about this one?
50.
Very good. 1/2 is 50%. How about this one? Very good. Di na to kalasa na tong time. Next na ta. Kaya at least nasabta na. Okay, so we go now to wala man tayo mahimo, no? Kaya mo ito ang controller. So, ito gining ilaylahon na itong controller na up, down, then the set or the mode, then the on and the off. Shinko or Panasonic. Okay. Nawala. Guys, nawala daw internet. Wala man. Nawala ba? Napa mo diya? Napa man sila. Napa na sila. Imuhara nawala diya. Okay, so if we're going to compare our previous na diagram, hinging, sir, balik-balik mo na, sir. No, it's not. No. This time, the model now is different. Diba? Ang model na to different as compared. So, i-review the model. Naman to bitaw sa to ang previous na docs or PDF. The model now is na different. Because ang output na niya is current na output. Ano siya kitawag 4 to 20 milliamps na output. Unlike atong the last time, it's a voltage na output. This time, it's a 4 to 20 milliamps. So pag may mga 4 to 20, so continuous na siya, no? Proportional na siya from 4 padong to 20. No? Linear na ang iyahang or proportional na response. Now, instead of using katorang kuan, ordinary lang, batuhon lang na solid state relay. This time, we're going to use the 4 to 20 milliamps na solid state relay. Dili katong 3 to 40 volts baka to. Ito, nakalimot ko sa itong previous na slides. No? Dili ka to voltage ay ang input. Dapat current 4 to 20. So that ang imong output sa imong heater, proportional po siya. No, dili pareha tong voltage lang, on and off lang iyahang output. So that's why this type of PID na system is also known as continuous output mode. Continuous siya. Okay? Continuous siya. And katong the last time po na example, no, if we're going to use a proportional pneumatic control bulb, of course with smart positioner, kani siya. So inaniyon pwede mo i-connect, no? Kani since this is the smart positioner, dira nimo i-supply imong i-supply na kuan, no, from sa imong hangin diya, no, man gitawag I to P. current to pressure. So supply na nimo diha. Dayon diri sa imong bulb, diha ang imong steam or hot na media. No? Pwede tubig, hot na tubig, pwede ba? If it is a heating control system. By the way, na nangutanan na lagi istorya. Okay? So, ina na siya. So, we review. Kataw kadumdum atong auto set. No? Auto tune. So, this time, we go now to kaning P. So, pasabot din sa P is dili na proportional gain, but rather proportional band. Take note, it's proportional band. It's the multiplicably inversely proportional to the proportional gain. Okay, so money may set. Okay, so take note kung i-zero po mo siya on and off. Okay, by the way, you can always download the manual. Ang default niya is 10. Since this is a temperature controller, then ang unit niya as default is 10 degrees Celsius. However, we're going to set the integral and the derivative or differential to 0. I-0 na nimo. Pag i-0 na nimo, then your system becomes proportional. Pero pag dili na nimo i-0, na PID na siya. Kaya nga naman, nakay value sa P na parameter, nakay value sa imong I na parameter, nakay value sa imong D. So, dili na siya proportional lang. That is PID. Okay? So, dapat i-0 nimo. So, if you're going to set this to 0, it disables the I parameter or I control. Ang 0 nimo I. So, simple naman eh. Dayon, kung makadumdum mo, kung asa pa dong tong auto-tune, so actually, you're going to press the up button plus the mode button or set the button. So, idungan na mo siya pislit until mo gawas na yung first na parameter na auto-tune, but you're not going to auto-tune kay pasabot sa auto-tune, PID man na siya, no? PID na auto-tune. Kung mingon lang kag proportional, that is manual, no? Manual tuning. So, ang P lang ang imong iset accordingly. The I and the D is disabled. Okay? So, that concludes our discussion. Okay, naka-attendance na. Gamay ramay na kayo naka-attendance na eh. Naka-attendance na mo eh, before ta mangundang. Kaya pag-attendance mo. Anyway, recorded man eh katong makamiss ato ang discussion. So, i-review lang niya. Ako na may post later sa group. Okay, wala na yung mag-attendance. Ako na i-stop recording. Wala na siguro tayo na ba? Wala na siguro. Calling once. Calling twice. Bye-bye. Bye-bye, guys.